morning from Cape Canaveral Air Station. I'm Larry Foss, and welcome to our 6th launch of the year and the 4th under the Lockheed Martin banner. This is actually the 7th Atlas. We had one on the West Coast, Vandenberg Air Force Base, where Atlas 45E, the last of our E models, was launched earlier this year. But we're here this morning to take Atlas Centaur 116 and the UHF follow-on satellite and put it into space. Launch time is scheduled for 11:27 Eastern Daylight Time. Hughes and the UHF satellite are no strangers to Lockheed Martin. Last January, UHF-4 was placed into orbit aboard an Atlas II. That satellite has been turned over to the Navy and is now in service for the Department of Defense. UHF-5, this morning's vehicle, and UHF-4 are somewhat different than their predecessors in that an EHF, or extremely high frequency package, has been added. This accounts for the need for an Atlas II model due to an additional 375 pounds added to the payload. All other launches were satisfied aboard an Atlas I. The Atlas vehicle will be launched from Pad 36A and has been given a clean bill of health and has the spacecraft. The spacecraft is actually 156 feet tall. The spacecraft has been given a clean bill of health also. Our vehicle this morning, as I said, is 156 feet tall. You're looking at a very nice picture of it there this morning. It is 10 feet in diameter and has the large fairing, the 14-foot diameter 14. We're about to come up on our T-14 weather brief, and we'll get the weather at this time. And I'm going to turn you on to the weather brief at this time. This is Atlas Launch Control.
Coast sea breeze is now starting to move inland. The only indication of an east coast sea breeze at this time is over extreme southern Florida. However, we are starting to get the initial indications that the winds at Tower 3, which are a little bit east of the complex, is starting to swing more to the south and eventually southeast. So we are starting again, like I said, initial indications of our sea breeze starting to set in. However, at this time, even if it would set in, it would not have, looking at the beginning of the window, would not have enough time to develop any significant cumulus clouds over the pad. So therefore, I'm very optimistic as far as having favorable conditions at the beginning of the window. Looking at radar, there is nothing in our local area and would not expect any for at least another couple, 3 hours down the road now. Looking at winds, they still remain favorable in the 10-knot region, and the only change to winds, again, will be the wind direction. Once the sea breeze does set in, see no threat to exceeding 23 knots. The only chance of that occurring would be on this afternoon and early evening, as we still see a high chance of thunderstorms in our local area. A good time any time after 4 o'clock this afternoon. Wind direction continues to be out of the southwest, but expect a change to the southeast here shortly. Looking at vehicle exposure, the only change, there is now a 0% chance of having lightning or exceeding 23 knots between the 11 and noon time frame. And once we get past the noon time frame to 2 o'clock, there's a slight chance of having thunderstorms with our east coast sea breeze. A little bit stronger chance after 2 o'clock, and right now the best chance of having local thunderstorm activity is after the 4 o'clock time frame. But again, right now, looking at the window, the beginning of the window, there is a 0% chance of a violation. This 20% is now more reflected to the middle and even more so the end of the window. As I said, there is a 0% chance of a launch violation at the beginning of the window. We are currently green on our launch permit criteria. Field mills are nominal and expect them to remain nominal until, I said, the only chance they would go out of specs would be towards the end of the window, and even more so this afternoon. And that concludes my briefing. Are there any questions?
This is Atlas Launch Control. As you just heard, the weather is looking extremely good for today's launch. As you can see, those of you that are watching the broadcast, the vehicle is basking in a full sunlight today, and it looks very, very nice. Our concern was that as the wind was shifting to the onshore breezes, we would probably see some buildups over the pad. Our weather guesser has indicated that we will probably have no problems with our buildups at the beginning of the window, which looks very good. Everything is green at this time. Weather in Central Florida, particularly near the ocean, can be especially dynamic. For this reason, it is essential for mission managers to keep a close watch on the surrounding weather conditions and movements during launch operations. Throughout the countdown, the Air Force Weather Station here at Cape Canaveral Air Station reports on current weather conditions and provides forecasts at 3 critical junctures. The first report comes just prior to rolling back the mobile service tower, exposing the vehicles to the elements. This occurs at about T-minus 135 minutes, which is about 2 hours prior to the actual launch. Actually 2.5 hours. If surface winds and potential for lightning are not a factor, the mobile service tower is rolled back, and a second weather briefing then comes at approximately T-minus 105 minutes to ascertain if conditions are acceptable for the start of cryogenic tanking. The third and final report, which you've just heard, comes near the end of the hold period at T-minus 14, and then again at T-minus 5. If at any time during the launch operations the conditions should deteriorate to the point of being a launch constraint, the Weather Office will be so advised and will advise the mission managers, and the launch will more than likely be delayed. In addition to monitoring surface conditions, the Air Force Weather Station has been releasing and tracking a series of helium-filled balloons. These balloons are tracked for up to 1 hour or 60,000 feet, whichever occurs first. Both radar and telemetry data is gathered by ground tracking stations to determine the speed and direction of upper atmosphere winds. This information is then validated and transmitted back to Lockheed Martin in Denver, where it is computer analyzed. A digital flight profile is designed to minimize aerodynamic loads and stresses on the vehicle as it is intended to fly through the atmosphere. The computer-generated flight profile data is then uploaded into the inertial navigation unit located on the equipment module above the Centaur. At liftoff, the Inertial Navigation Unit, or INU, sends signals to the Atlas engine gimbal actuators that steer the vehicle to compensate for the forecasted shear and upper level winds, if there are any. As we have heard, our weather forecaster has indicated very favorable weather conditions again at the opening of the window, which is this morning at 11:27 Eastern Daylight Time, approximately 24 minutes from now. The launch team is currently validating ground and airborne system components as they transfer liquid oxygen, or LOX, and liquid hydrogen propellants from ground storage tanks to the launch vehicle. The fueling process started 2 days ago when RP-1, a high-grade kerosene, was loaded into the aft booster tank. Loading of the cryogenic propellants, liquid oxygen and liquid hydrogen, began about 90 minutes prior to the scheduled liftoff. Liquid oxygen is maintained at a minus 290 degrees Fahrenheit, and liquid hydrogen at a minus 420 degrees Fahrenheit. The cryogenic fueling process begins with the loading of liquid oxygen on Centaur, preceded by chilling down the fuel transfer lines using liquid helium and high-pressure charging of the pneumatic helium bottles on board the vehicles. When Centaur LOX reaches the 95% full level, liquid oxygen fueling of the Atlas begins. The loading of liquid hydrogen on board Centaur is the final step in the propellant transfer process. Throughout the remainder of the countdown, fuel levels and temperatures along with tank pressures are monitored up to T-minus 2 minutes and 15 seconds when they are taken to flight levels and secured at T-minus 90 seconds. This is Atlas Launch Control at T-minus 6 minutes and 48 seconds and counting.
Cycle Centaur LH2, fill and drain valve. Roger. Valve cycle. Roger.
T-minus 6 minutes.
Helium chill down isolation valve functional check is complete. Roger.
Minus 5 minutes, 30 seconds.
Atlas LO2 at flight level. Roger.
Centaur LO2 at flight level.
Roger. LH2 at flight level. Roger.
Minus 5 minutes, 10 seconds.
Page 53 is complete.
This is Atlas Launch Control at T-minus 5 minutes and holding. Now, this is a planned hold, a 15-minute hold that is planned into the countdown sequence. The reasons, of course, for that hold are extremely necessary for the launch team to catch up on any checklist issues that might be delayed due to certain conditions that the vehicle is experiencing. At this point, we have no conditions working. We have everything is looking green at this point, so we are good for a opening of the window launch at 11:27 Eastern Daylight Time. Those of you that are watching the broadcast are looking at a back shot of the Mission Director Center and are showing what is actually happening in the Mission Director Center, where the decisions are made and the final decisions for liftoff as well as vehicle condition are determined. UHF F5 is one of 10 satellites ordered by the Navy's Program Executive Office for Space Communications and Sensors. The UHF, or Ultra High Frequency Constellation, provides the latest in worldwide satellite communications capable to the Department of Defense. Hughes is working under a contract to build and launch the 10 satellites, which are versions of the HS-601 body-stabilized spacecraft. Each satellite has 39 UHF channels in a variety of bandwidths and is compatible with existing ground equipment. The F5 satellite is the second in the series to incorporate the EHF, or Extremely High Frequency package, communications payload with 11 additional channels distributed between an Earth coverage beam and a steerable 5-degree spot beam. The EHF package provides enhanced anti-jam telemetry, command control, broadcast, and fleet interconnectivity communications. This payload will be on all of the subsequent satellites. This is the second of 3 UHF satellites scheduled for launch this year. All will be on Atlas vehicles here at Cape Canaveral. Incidentally, 3 other Hughes-built satellites will also be launched by the Lockheed Martin Atlas launch team here this year in 1995. This is Atlas Launch Control at T-minus 5 minutes and holding. Okay, this is Atlas Launch Control at T-minus 5 minutes and holding. We're 16 minutes away from actual launch time, or the opening of the window. The Atlas Centaur 116 mission ascent profile is prepared. We've got a video of what the profile should look like, and we'd like to show those to those of you that are watching the broadcast. We'd like to show you at this time. This is Atlas Launch Control at T-minus 5 minutes and holding.
launch of Atlas Centaur 116 will place a Hughes HS-601 satellite into orbit for the United States Navy. The fifth of 10 satellites to be launched by an Atlas and the second EHF payload, these UHF follow-on spacecraft will replace fleet satellite communication and LESAT spacecraft already in orbit. The satellite will fly on an Atlas II launch vehicle, one of the 4 Atlas configurations. Atlas II is a 2.5-stage launch vehicle. The Atlas first stage is powered by Rocketdyne MA-5 engines. The Centaur upper stage uses 2 Pratt & Whitney RL-10A-3-3A liquid hydrogen and liquid oxygen engines. Protecting the spacecraft during ascent is the metal payload fairing, available in 11 and 14-foot diameters. A Lockheed Martin payload adapter and separation system will support and then release the spacecraft from the Centaur upper stage. The following profile details the important events of the mission using approximate times.
5, 4, 3, 2, 1. We have ignition, and we have liftoff of Atlas Centaur 106. Everything is looking good at this time.
Shortly after liftoff, Atlas begins its initial pitch and roll maneuvers to attain the proper ascent profile. This will minimize aerodynamic loads.
Atlas systems are burning well. Looks like the Atlas PU is now in control. Both boosters and the sustainer look very good, burning properly. Looks like Atlas is burning just fine.
Booster engine cutoff occurs at approximately 2.5 minutes. The booster section is jettisoned seconds later. For the next 2 minutes, the Atlas will be in the sustainer solo phase. About 60 seconds later, the payload fairing is jettisoned. Burning propellant at a rate of 280 pounds per second, the Atlas will be nearly 100 miles in altitude, 228 miles downrange, and traveling at a speed of 9,000 miles per hour when sustainer engine cutoff, SECO, occurs, immediately followed by Atlas Centaur separation. Centaur main engine start, MES 1, takes place at approximately 5 minutes into the flight. Centaur and its payload are now in first burn, the longer of the 2 Centaur engine firings. This approximate 6.5-minute burn will inject the vehicle into a slightly elliptical parking orbit. After first burn main engine cutoff, MECO 1, Centaur, with the spacecraft, enters a coast period of around 11 minutes. At a guidance-calculated start time, just north of the equator, the Centaur main engines are reignited to burn for just over a minute, until the required intermediate transfer orbit is reached. After Centaur's second burn main engine cutoff, MECO 2, the Centaur provides the required separation spin-up and specific pointing attitude. Separation of the spacecraft will occur approximately 3.5 minutes after MECO 2.
And spacecraft separation, everything looking good.
Lockheed Martin is proud to participate in Hughes and the U.S. Navy's leading role in advanced naval communications by launching the 5th UHF follow-on satellite.
This is Atlas Launch Control at T-minus 5 minutes and holding. We're approximately 2 minutes and 30 seconds out of or actually 5 minutes and 36 coming out of the hold. We have a very important part of the countdown activity coming up in about 2 minutes, but the launch team is completing final programming of the inertial navigation unit. This programming is based on the latest weather data received at the Cape and is transmitted again back to Denver for Lockheed Martin, where the computer program is adjusted. Adjust is an acronym for the automatic determination and dissemination of just updated steering terms. The adjust system is the primary method used to design booster, open-loop pitch, and yaw steering coefficients for Atlas launch vehicles based on real-time measurements of the launch area winds. After wind soundings provide the wind velocity versus altitude profile, trajectory simulations are generated to determine an attitude versus altitude history that will satisfy specified adjust target and conditions. Pitch and yaw attitude versus altitude polynomial coefficients are then determined, tested, and transmitted for loading into the Centaur flight computer INU here at the Cape. This procedure was introduced as early as 1972 in order to maintain high % launch availabilities and has been extremely successful since then. This is Atlas Launch Control at T-minus 5 minutes and holding.
Ready to report to resume countdown. Atlas systems. Propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. RP1. Go. Vehicle electrical. Go. Flight termination system. Go. Propellant utilization. Go. Centaur systems. Propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. LH2. Go. Vehicle electrical. Go. Flight control. Go. CCLS monitor. Go. Flight termination system. Go. Telemetry. Go. RF. Go. Complex systems. Instrumentation. Go. Launch control. Go. Environmental control. Go. Booms. Go. Launcher. Go. Water. Go. Complex electrical.
Ready. Go.
Ground wind monitor vehicle loads. Go. TV control. Go. Sequencer. Go.
All right.
Operation
Go.
Safety Manager. Range, weather, and launch clearance forecast.
Go.
Launch director.
Go.
This is Atlas Launch Control at T-minus 5 minutes and holding. We're 1 minute and 36 seconds coming out of the hold, as you have just heard. The final polling of the Atlas, the Centaur, the spacecraft, the range, and the weather. Everyone has given a final polling of a go for this particular launch. Everything is looking very good for us today, coming out of the hold in about 1 minute and 15 seconds. This is Atlas Launch Control at T-minus 5 minutes and holding.
Stand by to pick up the count in 1 minute. T-minus 5 minutes and counting. Mark.
Spacecraft to internal power.
Roger.
Gas generator purge on.
Purge on.
Equipment module vent door squib to arm.
Squib armed.
Pyro valve switch to arm.
Valves armed.
Prepare water system.
Roger.
Minus 4 minutes, 30 seconds.
Prepare Centaur pneumatics.
Roger.
FTS to internal.
FTS on internal.
T-minus 4 minutes.
Atlas vehicle power to internal.
Atlas on internal.
Pyro power switch to arm.
Switch armed.
T-minus 3 minutes.
Centaur pneumatics ready.
Roger.
Water system ready.
Roger.
LC, spacecraft coordinator.
Go ahead.
Spacecraft is well, still reviewing a T on the list. I'll give you that status when that's complete.
Roger.
It's nominal at this point.
Roger.
Minus 2:35.
Securing Atlas LO2 topping.
Roger. Do we have spacecraft on internal power?
It's still in progress.
Roger. Arm switch to arm.
Engine preps complete.
Minus 2:15.
Start flight pressurization.
Flight pressurization started.
T-minus 2 minutes.
Centaur to internal power.
Centaur on internal.
Flight termination system to arm.
Atlas to arm. Centaur to arm. FTS armed.
LC, spacecraft coordinator.
Go ahead.
Spacecraft on internal power.
Roger.
Stable at flight pressure.
Roger.
Minus 90 seconds.
Securing LH2 tanking.
Roger. Ignition enable switch closed.
Ignition enable switch closed. Minus 75.
Securing Centaur LO2 topping.
Roger.
Minus 70.
MIB to auto arm.
Auto arm.
Engines ready.
Minus 45.
Status check propellants.
Go Atlas. Go Centaur.
Go Centaur. Pneumatics.
Go Atlas. Go Centaur.
Launch sequence start. Mark.
Minus 30.
MIB armed. LO2 and LH2 vent valves closed.
Minus 23. 22. Minus 20.
Ten, 9, 8, 7, 6, 5, 4, 3. We have engine ignition. And we have liftoff of Atlas Centaur 116 and the UHF F5. As we listen and watch to the Atlas launch vehicle being launched, let's turn now to Mr. Rod Gannon in the telemetry lab as he calls off the mark events.
Program in. We have Atlas PU on closed loop at this time. Everything looking good. All Atlas engines are up and running. Good startup signature. Atlas engines continue to burn well. Everything looking good. Atlas PU controlling right down the middle. Everything looking good. Booster engines continue to burn well. All parameters nominal. Atlas engines continue to burn well. Everything looking good. All Atlas engines continue to burn well. Nice clean flight. Atlas engines continue to burn well. Everything looking good. PU controlling right down the middle. Everything looking good. Nice nominal acceleration trace. We are now 20 seconds from firing the pyro valve in the RCS and ARCM systems. We have fired the pyro valve to pressurize the RCS and ARCM systems. Everything looking good. Atlas engines continue to burn well. Atlas PU controlling nominally. The isolation valve opened right on time. We're at 10 seconds from a nominal BECO. PU is open loop in preparation for BECO. We have booster engine cutoff. Everything looking good. And booster package separation. Sustainer continues to burn well. PU is back in closed loop control. Everything looking good.
Plus 180 seconds.
We are 30 seconds to nominal time to jettison the payload fairing. Sustainer engine continues to burn well. Everything looking good. "15 seconds to fairing SEP. Sustainer continues to burn well. And we have fairing jettison. Everything looking good. Nice clean accelerometer trace. Sustainer continue to burn well. PU controlling nominal.